Hi guys. Okay, so we've talked about using addition and subtraction when you're dealing with equations to solve for the variable. Today what we're looking at is 11.3 multiplication and division equations. Okay, so we're using multiplication and division now. Alright, so the essential question: how do you solve equations that contain multiplication or division? Alright, so let's look at an example problem here. This is supposed to say Diana up here. Okay, Diana has a cookie recipe that requires 12 eggs to make 3 batches of cookies. This should be of cookies here. Alright, how many eggs are needed per batch of cookies? Okay, so just thinking about this in your head, you could probably find the answer pretty easily. But if we wanted to use an equation, we could write it this way. So we're going to let x represent the number of eggs needed per batch, because that's what we're trying to figure out. So if I know that she's going to make 3 batches of cookies, okay, it says that here, and it takes her a total of 12 eggs, then if I'm figuring out how many does she use per batch, I could use multiplication here. This is a dot, so that's multiplication. So 3 times, what number is going to give you 12? Well, 4. Okay, so how many eggs are needed per batch of cookies? 4 eggs per batch. Okay? Now, the way that we're going to show this today, let's do it over here to the side. Okay, if you do 3x equals 12, you want to isolate the variable, the x. You want the x by itself. So I need to get rid of that 3. So we're going to do the inverse. Just like we did with addition and subtraction, we did the inverse to figure out what the variable is equal to. We're going to do the inverse, or the opposite, and this is multiplication, so I need to do division. So I'm going to go divided by 3, and remember, the equal sign is like the balance on the scale. Whatever you do to this side, you have to even it out on this side. You have to do the same thing. So I'm going to divide by 3 over there. These 3's cancel out, and I'm left with my x. So I'm going to have x is equal to, and what is 12 divided by 3? 4. So that's how you could arrive at that same answer just using the equation. This is kind of setting it up to think through what you multiplied 3 by. This is doing the same thing basically, but just using an equation. Alright? Technically this is an equation too, but it just looks different. These two look different. Okay. So using division to solve equations. We're going to use these words right here. You can pause the video and try to fill them in yourself really quick and then check and see if you got them right, or you can just watch me as I fill them out here. Okay? So you can divide both sides of an equation by the same non-zero number. Okay, so this is number, and the 2 sides will remain equal. When an equation contains multiplication, solve by, you're doing the inverse, solve by dividing both sides of the equation by the same non-zero, and we're using number again. Okay. So
here's an example here. When you have 9a is equal to 54, the way that we're going to show our work, this is multiplication between the 9 and the a. I'm going to go ahead and do the inverse, so I'm going to divide. So I divide by 9 there, I divide by 9 on the other side. These 9's cancel out. So what I am left with on that side is a is equal to, and what I'm left with on this side is 54 divided by 9, which is 6.
Okay, so my answer would be A is equal to 6. Now remember, when they say solve for the equation, you have to have, in your answer, you need to have a variable is equal to something. Same thing with addition and subtraction equations. You need variable equal to something. The next one, notice how the 6D is on the other side. Up here it's on the left, down here it's on the right. It doesn't make a difference. You still have to solve for the D. That's the variable. You want to know what that's equal to. So this is multiplication between the 6 and the D. That's multiplication. What you need to do is get rid of that 6. So I'm going to do the inverse, opposite. I'm going to divide by 6 on both sides. So what I'm left with on this side is D, and what I'm left with on the other side is 18 divided by 6, which is 3. Okay? So don't worry if the variable's on the left or right side. It doesn't matter. You still got to get the variable by itself. All right. So you guys are going to do the your turn, number 1 and 2, and then make sure you work the problem just like we worked these problems, and then show me your answer, and I'm going to check and make sure you did the correct work. Okay? So pause the video for a second, work those problems, and then let me know that I need to look at your paper. Okay. Make sure you guys have put your name up in the corner too, okay? So put your names up here. All right. Now, we're going to go on here to using multiplication to solve equations. So when an equation contains division, solve by multiplying both sides of the equation by the same number. The multiplication
property of equality. It says that you can multiply both sides of an equation by the same number, and the two sides will remain equal. Okay? It's just like a scale. If you multiply one side by 2 and you multiply the other side by 2, that should not have changed your equation. It's still the same equation, okay? So you can do that when you're working in math, and we're going to look at some problems here. All right, so A, I'm going to rewrite it over here. A is x over 5 equals 10. Okay, I'm rewriting it over here so we have a little more space. All right, so x over 5. This is division going on because anytime you see a fraction, that's division. So what this actually means is x divided by, remember, divided by 5. So the opposite of division is multiplication. So I need to multiply. And I need to get rid of that 5. So the way that you're going to do this, since 5's on the bottom, I want to multiply by 5 over 1. I'm going to multiply. That's basically multiplying by 5. Instead of dividing by 5, I'm multiplying by 5. But I'm writing it as a fraction. So I want you to see that this 5 cancels out with this 5. Okay? Because if I multiplied across, I would get 5x, right? If I multiplied across on the bottom, I would get 5. So if I had 5x over 5, like this, over here, if I had 5x over 5, those 5's are going to cancel out, and all you have left is that x. Okay, so that's basically why you multiply by 5. So now I have x on this side, and I still need to multiply by 5 on that side. So I can write it as a fraction, or I could just write multiplied by 5, but this would be 10 over 1. So my x is going to be equal to 10 times 5 is 50, so my x is equal to 50. Okay? X is equal to 50. And if you go back and check yourself, if you put in a 50 there, I don't know why that's so blurry. If you put in a 50 there, where that x is on your paper on A, 50 divided by 5, is that 10? Yes, it is. Okay? So that's one way you can check yourself.
So that one's 50. The next one, B. It's 15 is equal to R over 2. Okay? So on this one, your variable's on the right side, but it doesn't matter. You're still solving it the same way. It doesn't matter if your variable's over here, on the left, or on the right. I need to get rid of that 2. So I'm going to, instead of dividing by 2, I'm going to multiply by 2 over 1. I just like to show it as a fraction so that you can see that these 2's that are diagonal from one another, they're going to cancel out. So this would be, your 2's are canceling, what you're left with is R. Okay? And on this side, I'm going to multiply that by 2 over 1. So 2 times 15 is what? 30. And 30 over 1, if you multiplied 15, would be 15 over 1. So 30 over 1 is 30. So your answer is 30. And if I put in 30 into the original equation, 30 divided by 2 is equal to 15. So you should always go back and check yourself. Alright, so you guys are going to do number 1 and 2 and show your work the way that I showed my work here. When you get it done, let me know and I'll come and check it. Okay? Now, let's see here. I'm trying to think if I want to do some type of prize for people today. Let's look at the back here for a minute. Let's say if you can find a number 5 somewhere on your paper, let Mr. Hire know, let me know, and I'll try to get you some candy, okay? Number 5. Okay, so on the back, Juanita is scrapbooking. We're looking at equations to help us solve some problems. She usually completes about 9 pages per hour. One night last week, she completed pages 23 through 47 in 2.5 hours. Did she work at her average rate? Okay, so her average rate is 9 pages per hour. Now, the way that you could set up this problem, let's let N stand for the number of pages that she read divided by 2.5, which is the hours, equals 9. Okay? So, whatever, this is the number that she reads per, this is the 2.5 hours. If she's on her average, it should be 9. Okay? We want to figure out what this number would be up here. Alright, so I'm going to pause the video. You guys figure this out. If you read 23 through 47 pages, that's 26 pages, or 25 pages, I guess. 25 pages. So what you want to do, once you figure this out, solve this equation for N, and if it's less than this, then I gotta think through this for a second. Well, you guys go ahead and solve it. I need to work it myself, but go ahead and work this out and see what you guys get for N, okay? And then once you finish N, take a look at 4, see if you guys can figure out how to solve an equation to solve this problem, and then if you're struggling with doing that, maybe look through this part down on the bottom first, and then come back up to this and see if you can come up with an equation. All right? So, thanks for listening, and nice work.